Oracle provides a graph database within Oracle Database and Autonomous Database to help discover insights using the power of graphs, relationships, and visualization. This video shows the use of graph features of the Oracle Autonomous Database to detect patterns of potentially fraudulent transactions. One such pattern is circular payments. That is, money is transferred out of an account, passes through 4 or 5 or more intermediate accounts, and then lands back in the source account. A graph is made of nodes and edges that represent entities and relations. For example, here the nodes represent bank accounts and edges represent money transfers between those accounts. This demo has 3 main steps. First, create a graph from the accounts and transactions tables. Second, run some graph algorithms such as Centrality to identify accounts to investigate. And lastly, execute some path queries to find circular payment chains involving those accounts. In the first step, the PGQL create property graph statement defines the graph model on the bank accounts and bank transactions tables. It specifies, for example, that account ID is a property of the accounts node and that the source ID and destination in the bank transactions table determine the source and destination nodes for the edges. The transaction amount becomes an edge property. The next step is to execute some graph algorithm to identify possibly suspicious accounts. This is done in the interactive J shell where we can execute Java code or PGQL queries. The J shell works with the in-memory graph engine, also known as PGX. The PGX server is already started, so we connect to it and then load the bank transactions graph into memory. Once that is done, we run between its centrality and list the top 10 accounts, that is those with the highest centrality value. Lastly, let's query for and visualize circular payment chains in the GraphViz application. Account 934 had a high centrality value. So let's look for circular payment chains of length 4, and we see that there are 3 of them. Our financial services customers have found that these chains are usually of length between 3 and 6 hops, where each hop is a money transfer between accounts. So let's query for all circular chains of length up to 6 hops. In this video, we have seen how to model tabular data as a graph, how to execute graph algorithms to find important nodes, and finally, how to run graph queries and visualize the results. To learn more, go to oracle.com/go/propertygraph.